Everyone, I'm Samadhi Pakasha, and today I'll be talking about something that's really close to where the future of AI and search is heading, something called Open Deep Search or ODS. This work was released in March 2025 and is designed to challenge the current status quo in how we think about AI powered search. Right now, we are in an era where powerful search tools like Perplexity or GPT-4o exist, but they are all locked behind closed source systems. The idea behind ODS is bold yet simple. Why not build something open source that performs just as well or even deep search? There are two ways in which you can search the data. One being traditional search, that is Google search, or using any search engine. What happens here is that the most authentic websites are generally not the top ones due to paid promotion. This results in the users actually getting the data that cannot be considered reliable. This can be proved because the data says that Google search plus search engine results page combined gives a 30 to 40% accuracy on frames, that is factuality checking. However, with deep search, that is ruled out by LLMs, you get a fact-checked and nicely curated answer wherein you don't really need to do the browsing stuff. In fact, the LLM does it for you from the standardized and trusted websites uh, like Wiki, Arxiv.edu, and .gov. Data says that ODS achieves 75.3% accuracy on frames, that is 2x of Google. So that's pretty cool. Let's look at the research gap and the need for ODS. Research gap. Closed source systems dominated deep search, Perplexity, and OpenAI. This led to an increasing gap in the dominance of these LLMs as compared to the open source counterparts, for example, OpenPerplex. So there was a need for a system that can educate people about deep search. A solution, a tool named Open Deep Search that bridges the gap by combining the state of the art LLMs with an open search tool. This combined setup achieves a 9.7% accuracy more as compared to GPT-4o on frames, and the plus point being that it is fully open source. So how does ODS actually work? You can think of it as three major parts working in sync. Number one, the open search tool. This is the backbone of web retrieval. It takes your query, rephrases it to make it more specific and structured, and then uses SERP APIs to retrieve results from credible sources like .gov or .edu sites. Number two being the open reasoning agent. This is the brain. It decides, should I search more? Should I calculate something? Or should I just think? There are two versions of this agent, React and Codact, which we'll dive into shortly. And the number three being modular LLM integration. And finally, you're not logged into any one model. You can use anything from open LLMs like Llama 3 or DeepSeek to closed ones via API. That makes it super customizable and future-proof. Here's the flow in action. A query comes in, the agent decides what tools to use. Search or compute tools are triggered, and finally, a clean, verified answer is returned. What makes this setup really exciting is how easy it is to adapt. Want to swap the LLM? No problem. Want to add a new tool? Just plug it in. Open Search tool. Now let's take a closer look at the Open Search tool. This is the engine that powers the actual search part of ODS. So what does it do? First up, query rephrasing. Let's say a user asks, how can I make my internet faster? It doesn't just pass that question to the search engine as is. Instead, it breaks it down to technical aspects like bandwidth, latency, and Wi-Fi signal strength, which leads to more technical and precise search results. Next up, smart retrieval. It uses structured metadata like the title, snippet, date, and domain name, and ranks the sources based on credibility. For example, government.gov and educational.edu domains are given higher preference, so you are less likely to get clickbait blog articles. Then we have context augmentation. It doesn't just scrape the top website, it extracts and ranks the most relevant passages using passage embeddings. These passages are passed onto the reasoning agent for deeper understanding. And finally, custom API handling. It has specific optimizations built in for sources like Wikipedia, Archive, and PubMed. The scientific and encyclopedic knowledge is well covered. Now comes the open reasoning agent. This is the brain of the system. There are two flavors of this agent. Number one, React agent used in ODS version 1. It uses chain of thought prompting. So instead of directly answering, it says, let's think this step by step. And it follows a thought, action, and observation pattern. Actions can be things like search the web, calculate something, or just continue thinking. When it's not sure about the answer, it tries multiple reasoning paths and picks the most consistent one. This is called self-consistency. Number two being Codact agent, used in ODS version 2. This one's even cooler because it introduces code of calculation. It literally writes Python code to do symbolic and numeric reasoning. So if the question is something like, if I invest $500 at 5% compound interest for 3 years, then what's the return? It writes the math code and returns it. It's much better than older agents that relied on static JSON logic. Behind the scenes, it uses a framework called small agents for orchestrating tools. Let's look at ODS1 and the React agent. This agent is built on chain of thought reasoning, where the model talks itself through the problem before answering. It works both in zero shot and few shot modes. It can think and reflect, trigger a search, or perform calculations using Wolfram Alpha. If it's unsure, it runs multiple reasoning paths and uses self-consistency to pick the best answer. It's great for semantic questions, general knowledge, or any scenario where layered logic helps. Now, how does ODS version 1 work with React? Query comes in, OpenSearch tool provides the context, and React agent takes it over. Now, based on the scenario, the agent chooses one of the three options: continue thinking, search again, or calculate something. And if it's still unsure, it goes with the safest bet, uses cluster voting to find the most consistent answer from multiple tries. This way, it avoids hallucinations and maintains factual accuracy. Kodak agent. Now comes the real game changer, and this is used in version 2. React is great, but it struggles with math, code, or anything symbolic. That's where Kodak shines, because it can write and execute actual Python logic. Why that's powerful? Because code doesn't hallucinate. Code either runs or it doesn't. And that makes this approach ideal for things like data analysis, statistics, timelines, finance, etc. Now, how does Kodak work? It interprets the query, writes the logic in Python, runs it using a tool framework called small agents, and then integrates the result into a clear answer. The results are quite impressive. ODS V2 with Kodak plus DeepSeek R1 hits 75.3% on frames. With GPT 4.0 search preview, it hits 65.6%. And the coolest fact being, it takes just 3.39 searches per query on average. So it's both smart and efficient. Let's come to benchmarks. So let's talk evaluation. First, we have simple QA, a benchmark made by OpenAI to test quick factual recall. It contains 4,326 short factual questions across topics like TV shows, science, politics, geography, etc. So pretty much every domain is covered. And here's the interesting part. Responses are judged not by humans, but by GPT-4o itself. So it's a model versus model test. And ODS holds its own here incredibly well. Now, if we see the results, we can see that ODS V1 and ODS V2 perform very much at par and even better than Claude 3.5 Sonnet and O1 preview models. And the best part being that by plugging in DeepSeek R1 and advanced models using the plug and play framework, you can get even better accuracy than the ones which use Llama, because DeepSeek is a much advanced model. Then there is Frames, a much harder benchmark. It contains multi-hop questions. So you need to combine facts from multiple sources. For example, what was the GDP of France when the iPhone 6 was released? That's not a single answer lookup, right? That's timeline reasoning plus data lookup plus validation. And here's where ODS shines. It decides when to stop searching, when to continue, and what to extract. So it's incredibly smart. We also found that ODS V1 performs more searches with weaker LLMs like Llama, and ODS V2, because of its coding capabilities, it's much more efficient and accurate. Here is the performance comparison on Frames dataset. Now, you can observe here that ODS V2 plus DeepSeek R1 takes approximately 3.39 queries, 3.39 searches per query, whereas Gemini Pro with 15 queries, 15 searches per query still performs worse than ODS V2 plus DeepSeek R1. So you can imagine the level of accuracy that this open source model has achieved. Gemini takes 5 times more searches and still it's not able to reach where ODS V2 and DeepSeek R1 combined reach. Ablation study. To understand what really makes ODS work, we ran ablation studies. This basically means remove one component and see what breaks. Turns out every part, from query rephrasing to passage extraction to chain of thought or chain of code reasoning, adds value. Also, just upgrading the base model from Llama 3.1 to DeepSeek R1 boosts the score significantly, as we can see in the table. So it's not just about fancy fooling. The integration is what makes it powerful. So here is an example. A question from Frames was asked: how many years elapsed between the release of the song I Think I'm Go-Go by band Squeeze and the theoretical premiere of E.T. the movie? Now you can see that ODS is really great here. It gives you structured, logical, multi-step explanations, factual references from known sources, and clarity of what it did behind the scenes. So you can see that the whole syntax is visible. It's showing that it has initially thought about it and then it has taken action. And based on the observation, it has again gone into the thinking process until it is satisfied with the answer. So this isn't just useful for users, it's essential for trust, especially in fields like education, health, or finance. So to conclude, Open Deep Search is a fresh take on how we approach AI-based information retrieval. It shows that open source tools can absolutely match and even outperform closed alternatives when designed well. And because it's modular, transparent, and adaptable, it's ready for what comes next. Better models, plug them in, new tools, add them. The system grows with the ecosystem. And the biggest part being the whole code is accessible for everyone so that people can learn how these things are working rather than just using them. Thank you for all your time. I hope this presentation helped you understand what Open Deep Search is, how it works, and why it matters. If you're curious, the full paper is on Papers with Code, and I would love to hear your thoughts or questions. Let's build an open, trustworthy, and intelligent search ecosystem together. Thank you.